Good morning, everybody. Well, not everybody, because not everybody's here yet, but good morning to those of you who are here. Welcome to this session. I hope you all had a good night. I know the session yesterday on health data governance and law was fascinating, but it exhausted my brain. It's outside of my field of expertise, so I had dreams about it last night. So I hope you had dreams about different things. Okay, so this morning we have a session on opportunities to harness artificial intelligence and machine learning for health in Africa, which I think is a very topical topic. It's very timely. It's obviously a big theme of what we're trying to do in DSI Africa. It's also a very complicated and at times opaque topic. You may be tracking all the AI media at the moment and releases of new models and new platforms and so on. And I was just talking to my team over breakfast this morning and saying it's quite difficult to kind of navigate this space. There's so much changing, so much development, so much PR, but underneath it, there's real value that we can tap into, and many of us are already tapping into that. So I really hope that the session will be helpful. It'll help you make sense of where AI and ML fit into this landscape, help make sense of some of the sort of PR fluff around it versus the real value, and particularly with a focus on the value for Africa. So I think a lot of our speakers will be touching on how does this all land and how does this position itself within the context of Africa when so much of the development is happening outside of the African context. So we have two excellent speakers, keynote speakers, and then a series of other excellent speakers. So it's quite a packed program this morning, so I'm not going to take up any more time. So our first speaker is Deshan Moodley, sorry about that. So Deshan's actually joining us virtually online, so he's saving his carbon footprint for other purposes. So Deshan is the SARCI Chair, South African Research Chair, for those of you familiar with South African research landscape, Chair in Artificial Intelligence Systems. He's also an associate professor in the Department of Computer Science at my university, University of Cape Town. He's the co-director and co-founder of South Africa's National Center for Artificial Intelligence Research, and he's currently based at the Paris Institute for Advanced Studies. And critically for today, he's explored AI systems across diverse domains, including health, energy, finance, and Earth observation domains. So he's got a lot of experience, and I hope he's going to bring some nice insights. So Deshan, are you online?
Yes, I am. Yes.
There we go. There we go. Hi, Deshan. Carry on
Hi,
when you're ready.
morning.
Thanks.
I'm just checking that it's switched to full screen mode.
Yes, we can hear you. If you could turn it up a little bit, be great.
Okay. Is that any better?
That's great. Thank you. Carry on.
Okay. Thanks for that introduction, and thanks for inviting me to give this talk. So I only have 20 minutes, so I would not be able to cover everything. But I want to touch on three things in the talk. First, a brief overview of AI and AI systems. As Chris said, that there's lots of contention and some competing definitions and what's going on in the field. So I'm just going to give you my perspective. Touch on some emerging trends in the AI research community, and also to talk to you about a fun projects that we've been doing recently, which is to have a blue sky to really stretch our imagination and to come up with a blue sky idea of how we can use AI to advance health and research and practice in Africa. So just to, I'm not sure how much everyone's familiar with AI, but just I think to step back a bit and really to talk about what is AI. And so I think in terms of humanity, the notion of intelligence and how we think is certainly been occupying many researchers, and we are intelligent beings. There's no single definition of intelligence, and that also has been evolving over the last few years beyond just the notion of an IQ test, for example. So AI intends to build machines that are intelligent, and it studies how to build these types of machines, and also to understand the behavior of these machines. So if you're looking for a nice source of what's going on in AI and what it is, I really would advise you to read the 100-Year Study on AI. It's a multidisciplinary team, and it's a very useful document, and the link is there. I think you will get access to these slides. So another difference, or something that always crops up, is what's the difference between automation and intelligence? So we have computer systems which automate certain tasks, and they have bits of AI in it. And when people say, well, here's the AI system, so the boundary is somewhat fuzzy. If you think back 50 years ago, we had the first computers that could do complex calculations. And at that point, people probably commented, these are really, really smart machines. And now, to call something intelligent, people are a little bit more discerning. They certainly wouldn't confer the notion of intelligence on a computer that can calculate the sum of 100,000 numbers. So intelligence, even human intelligence, is quite hard to measure. And so for AI, we usually traditionally have been setting the bar at human abilities. So if a human can do a complex task, can we create algorithms and software to allow the machine to do those tasks? So it's useful to see what happened in terms of machines in human history. So we had the tools, and that had a particular impact on human ability. Then we had more mechanical machines. And then, of course, the advent of a computer, and these were programmable machines. So we would retask the machines or repurpose them using programs. And now where we are at is we don't think of a computer as a standalone PC, which came around probably in the 80s and 90s, but we think of it as a connected system. So it's not just a computer, one device, it's a connected system. It could be in the cloud, it could be accessed via your cell phone. And now we have these kinds of adaptable, learning, creative, and connected systems. And these systems are growing and self-evolving. And that's quite an important part. So an AI-enabled computer system, so I'm talking about a system, this connected thing, and an AI-enabled system can learn from experience. It can adapt to changing situations. And now, as you all know, it can even surpass humans at specific tasks. And what's really exciting at the moment that everyone's wants to know more about is these kinds of generative AI. Because now you've got systems, AI-enabled systems that can perform creative tasks, creating new art, music, and of course, text, like ChatGPT. So this learning and adapting ability, together with its being connected and being able to access and fuse vast amounts of information in real time over networks, is at the core of AI systems. So let's take a simple monitoring and decision-making system. And this is just to give you an idea for many of the notions that I will introduce in the talk. If you've got some environment, so it could be the natural, biological, or even a virtual environment, and you've got some sensors that are embedded in this environment. This could be watching the air quality, the temperature, maybe some video images. And then, of course, you've got some individual sensors like wearables that can measure your heart rate, blood pressure, and so forth. And then we would use an AI system to determine what's going on, what's the situation in this environment, to analyze the situations, and these are like will learn or detect some qualitative. So the sensors will produce quantitative measures or measurements or observations, and then you need to use some model or theories to analyze that and convert them into some situation of interest that's happening. And of course, then you can use the AI to predict how situations are going to unfold in this environment, and then one can do some decision making to avert some adverse situations. The interesting thing that's happening now is, which I'll touch on again, is that now with ECG signals, there's some new results that are showing that we can estimate your mood or emotion with some surprising accuracy, whatever that is. Of course, this is very contentious. And now we want to look at a more holistic notion of well-being beyond just physiological parameters. So where will we, the human, fit in? And traditionally, when we thought about AI, we thought about these autonomous systems that can take over the world, killer robots, where this AI evolves into something that we don't really have control over. But the new way of thinking about it is that really where we're moving is towards this notion of human-centered AI, where the human and the machine interact. And this is already happening. And so in this case, we've got the AI and the kind of computer system, the humans deliberating and observing, the AI system deliberating and observing the environment, and then interacting. And then that becomes a kind of shared compact that that occurs between human and machine. So in this case, the AI learns and adapts to the human user. The human user sets, of course, tasks and learns to delegate certain things to the AI. And of course, what really needs to happen is to build a trust relationship. So this notion is called augmented AI. And the idea here is to build these intelligence systems that amplify rather than replace humans, especially their cognitive power. Recently in the AI literature, this is also referred to as hybrid intelligence. And this is now being thought of as a new type of intelligence that will emerge, which is far beyond just human intelligence alone, machine intelligence alone. So taking this perspective of AI brings about a number of challenges. Of course, this environment I showed you is a very dynamic environment. So you need to have models that learn from noisy observations, erratic readings, and so you need some model learning, like what machine learning does, so data-driven. And also, you need to capture human knowledge to know what are adverse conditions and how they link to each other, maybe some causal relations. And of course, the user would have changing goals or even vague goals, and how do you specify this? And then the human and the AI, from this kind of hybrid intelligence, these two systems will evolve. And how do you update the human's idea of the machine and the machine's idea of what's going on with the human? So there's also cognition. So the AI has to have this notion of knowledge, be able to represent it, acquire it. And the harder thing to do is to discover how new knowledge, or for the machine to be able to discover new knowledge, this epistemic process of how we as humans discover new knowledge. So the system must incorporate and continuously update a mental model of the user and establish a trusted relation with the user over time. So within the AI community, and this is, again, something that has interestingly emerged. Historically, classical AI was about mostly based around logic or symbolic AI. And this was very knowledge-driven. So it's like deductive logic or deductive reasoning. And this mimics deliberative thinking in humans. Knowledge-based approaches capture and specify expert knowledge and this deductive type of reasoning that humans use. But of course, there's some assumptions, is that we can actually capture all human knowledge as rules, which is not really possible in my view, and then we can update it so as our knowledge changes. What's gaining, of course, a lot of attention is the bottom-up or the data-driven AI, which is now at the forefront, which is like machine learning, which are these powerful models that can pattern recognition algorithms, which can build models from data. And the assumption there is that all knowledge is captured in data, and because these are systems that just purely learn from the data, and the humans can typically be kept out of the loop, and humans might not even understand how these models are built and the rationale for their predictions. What's gaining traction is an hybrid approach, combining both the bottom-up and the top-down approach. So 20 years ago, the knowledge-based techniques were at the forefront. There was a huge wave or hype about the semantic web, which was very knowledge-based, and they produced these intelligent software agents and the notion of ontologies, a whole lot of languages and tools, and it really elevated knowledge-based AI in the early 2000s. And this community was focused on the cognitive aspects of the cognition. And another aspect that came out is, which is still very important today, is this notion of interoperability and communication. This is the levels that we're using in this community. It comes from semiotics, so that when we communicate, and whether it's systems or machines, at the syntactic, semantic, pragmatic, and social world. And the semantic web reached semantics, but didn't really move beyond that. Towards the end of this, the semantic web era, there was this notion of the pragmatic web, which was going to go beyond the semantic web, but that never really came to fruition. On the deep learning side, most of you would know about deep neural networks. What's happening currently is there's a lot of interest on continual learning or incremental learning, which is to produce these models that are constantly updated as well changes. And it's a sequential training protocol, and you just specify the features of the solution, like what the model should target. And it works, unlike DNNs, which worked on fixed data sets and stationary environments. These continual learning models will focus on changing in non-stationary environments. So they can be used for change detection. They need mechanisms to automatically do model updates, and then you specify the features. We've got a recent paper which covers a lot of the topics, and you can read more about it in the paper. And what also is new in machine learning is these new wave of techniques called spatial temporal graph neural networks, and they are used to model erratic flows in complex environments with noisy observations. They've mostly been used. The benchmark problem has been on traffic in a city. So you've got sensors at various points in the road network in the city, and the problem is to predict the flow of traffic or speed of traffic at all these points at any time in the day. And that's, of course, quite a difficult problem. There's high potential to apply this to causal flows in clinical observations. So this is a very exciting area that's opening up. Building AI systems is quite complex, and there's some work about how we should build these hybrid systems. There's some challenges, the interoperability, dealing with uncertain sensor observations, and of course vague notions in terms of situations. You need some high-level abstractions, because there's a whole software engineering, and how to compose these complex workflows that you typically would see in an AI system. I'm not going to mention too much about that. And there's also some interest about how developers, AI systems, and users would work together, and which AI techniques they would use. And then this notion of we need to study machine behavior as a social phenomenon. And if you're interested in that, there's a reference which you can have a look at. And here's a architecture for a typical hybrid AI system. So in this case, based on these notions I introduced, you've got a monitoring layer, a situation analysis, and then of course the decision-making and action layer. So you can use top-down, like the knowledge-driven approaches based on expert knowledge. You could have continuous learning to learn machine learning models using just data-driven approaches. And then these must interact, and here's a possible architecture for them. So I've touched on some things that are emerging in AI, but there's a few more things that I want to talk about, which is scientific knowledge discovery. This is at the forefront of AI. I think most researchers see this as the next big thing in AI. There's the how do you create this kind of robot scientist or AI scientist? And this is quite hard to do because I think we don't have full understanding of exactly how the scientific process works. We can draw from philosophy of science. So typically, traditionally the inductive and the hypothetical deductive methods. And there's a more recent theory called the abductive theory method. We've started in our group to explore this as an AI system. It works well with this kind of top-down and bottom-up. So you've got the data-driven aspects or AI, which we can use for phenomenon detection from the data. And then you've got this theory construction, the kind of top-down, which maintains the knowledge that we know. And then as soon as there's a phenomenon, unexpected phenomenon, we try and provide possible explanations or hypotheses for this. This is quite an exciting approach, which we're just starting to explore. In terms of AI research, there's been so if you look at AI research in practice, and again, in the research side, there's lots of hype. In the practice side, you've got some phenomenal things that are moving into practical application, like, ChatGPT. And what's happening is that there's a kind of the gap between the research and the application is becoming smaller and smaller, and it's almost melding into this continuum. Things again just
hi, Deshan, just a couple more minutes, if that's possible. Thank you.
Yep, sure. What's happening is these four trends that I want to highlight is this notion moving towards human-centered AI, interactive decision-making, which is linked to this human-centered AI. And I've also spoken about scientific knowledge discovery, and then the notion of taking a systems perspective rather than just focusing on building these individual models or components. So there's an interactive decision-making system, which you can always look at that paper if you're interested in that. And this gives you an idea of where the field is heading. You've now got human-computer interaction as a field, AI, and cyber-physical systems, which uses this notion of digital twins. And these are all converging towards this field of human-centered AI. So on the digital twins, so coming from this aspect, there's a lot of work on the health side in terms of smart cities and precision public health. And of course, then combining that with AI, because all smart applications need to incorporate AI. On the Internet of Things, there's now a move toward personal health monitoring systems using wearables, and low-cost wearables are definitely on the horizon. And this also going to have a huge influence on precision health. I mentioned the notion of detecting mood and emotional state from ECG signals. And of course, this will have huge impact on mental health and overall well-being. And on the public health side, there's now agent-based modeling and simulation is emerging as something that is quite important in epidemiological modeling. And this is just to finish off. I'm not going to go too deep into this, as this was our exciting project, which we just presented in an AI conference in August. You can read a lot more about it in this article. It's like a kind of position paper. And we took the One Health and the notion of preventative health, AI systems, digital twins, and then we combined all of this to see where this will take us. we used all of those perspectives, and then we came up with, in our view, reimagining healthcare in Africa, which is a 3D digital twin. It's like a smart city. People are embedded in this. They can do real-time simulation in it. The model's being constantly updated in this 3D digital twin, like a smart city. People's movements, there's kinds of wearables that are modeling individuals. And all of this is accessible by health modelers. And of course, there's lots of ethical issues. You can read up a bit more about that if you want, but it's nice to have this bold vision to take us forward. So where are we going in the future? I mentioned all of this. I think the exciting areas are interactive decision-making, scientific knowledge discovery, this interoperability, the next level, and new versions of explanation for the interface between humans and AI. And then my concluding remarks, I think there's high potential, as I've shown you, for AI to bring about structural change in Africa. I don't think the low resource setting, we've worked on technologies in digital health previously in our group. There is ways to overcome the low resource aspect. The biggest burden I see is the social side. So it's if you're looking at these digital health systems, the social technical system, getting communities together, the health practitioners, the computer scientists, the social scientists, that's really, really hard to do. And what I would say as my last closing remark is that what we need is more dynamic and agile research and innovation ecosystems. We've started working on this, but I think this DSI Africa Forum is definitely a good platform to create such ecosystems. Here's 2 references, and I think you should have access to the slides if you want to read up a bit more about that. And thank you for your time and attention.
Thank you so much, Dr. Moodley. That was very, very interesting and just scratching the surface on a very dense and rich domain. My name is Bonnie Joubert. I'm from the National Institute of Environmental Health Sciences within the National Institutes of Health. And I just want to take this opportunity to thank the Coordinating Center for an excellent meeting. Let's give a round of applause to the Coordinating Center for all of your behind the scenes work. An excellent job planning and organizing this meeting. It's my pleasure to introduce Dr. Akbar Walji. Dr. Walji is an accomplished physician scientist in healthcare policy and innovation, focusing on using machine learning and deep learning techniques to improve healthcare outcomes. He holds several key leadership positions at the University of Michigan in the United States, including serving as faculty lead for the IHPI Data and Methods Hub and the co-director of the Michigan Integrated Center for Health Analytics and Medical Prediction. He's also the convener of the eHealth and Artificial Intelligence program. Dr. Walji's work is aimed at improving healthcare access, quality, and efficiency, particularly in resource-constrained settings. He employs novel machine learning techniques to develop AI-enabled decision support systems and tools to facilitate personalized care for disease management and healthcare utilization, with the ultimate goal of delivering efficient, effective, and equitable care, both locally and globally. Dr. Walji, thank you.
So thank you for the kind introduction. So I'll jump right in because I know we're running a little behind. So the outline for today's talk is, again, a little bit of what my predecessor to the talk gave was a little bit about what is artificial intelligence and where does generative AI fit into this? Opportunities of using AI for health research in Africa, using exemplars in cancer care delivery, as well as community-based health data. And then talk about using of AI to ensure privacy and data security. And then finally, trust and bias in AI. So I know you're going to look at this and you're going to be like, oh, that's a lot to cover in 20 minutes, right? So the reality is this is not going to be an exhaustive talk about each of these topics. I could probably spend an hour on each of these. But what I want to do is really give you exemplars for each of these things And I know we have a diverse audience here today, everybody from trainees to experts in ethics and data science. And so again, I'm hoping to give you a flavor for each of you, and hopefully this will resonate with you. So again, we'll go through this pretty fast because the talk before talked a little bit about this, but what is artificial intelligence, right? So it's when a computer does tasks usually done by humans because they require human intelligence and discernment, right? But it really focuses on three key skills: learning, reasoning, and the self-correction. Now, remember, the self-correction is a big thing, and not all AI systems actually self-correct. So just to think about that. Machine learning is an AI subfield using statistics to help computers learn from experience and develop patterns. So some of you may be familiar with the traditional programming. I don't know how many of you still use C or C++, but in traditional programming, you have data, and then you kind of program with C or any other language, and then you get that outcome or that output. But when you're using machine learning, you give the computer the data and the outcome, and it actually develops a program, an algorithm that they can then potentially use in your work. Peter Dominguez at the University of Washington, not Washington University, but University of Washington, analogized machine learning like gardening. The soil is the data, right? So all that all the dirt in there, really all the nutrients. The seeds are the algorithms. The plants are the programs. You can't forget the gardener. This is not magic. The human has to be engaged and has to be involved. So approaches to pattern recognition. Again, another way of representing what artificial intelligence is. So this is a box of artificial intelligence. Machine learning is within artificial intelligence. And then you have various kind of methods under machine learning. Support vector machines, random forest, generative AI, computer vision, reinforcement learning are just some exemplars, okay? Generative AI, you're hearing so much about ChatGPT. What is that? Where does it fit? Again, artificial intelligence, generative AI, large language models, and then ChatGPT just happens to be one large language model. There are other large language models like BERT, MedPalms. MedPalms is more medically based and more diagnostic related. So where is the opportunity here now and beyond? So I'm going to give you an example of how technology in East Africa has revolutionized the way we do financial transactions, right? You went from a home phone to a financial bank to now a mobile phone using M-Pesa or mobile money to do daily transactions. How can we use data in better ways? How can we use better data in healthcare? Can we use the state-of-the-art technology and data analytics to rapidly advance care options? And that's the key here. And I think that's where the opportunity lies. So the example that I'm going to give you that some of you may have heard from the new UO1 that was recently described yesterday was in the context of colorectal cancer, but in my mind can apply through almost any cancers. But let's talk through this example particularly. So colorectal cancer is rising in Africa. So in the United States, when you turn 45, you get traditionally a colonoscopy as a screening modality to remove polyps that potentially can turn into cancers. The risk of developing cancer in the United States, 45 and above, is about 3 to 5%. We're seeing that same to 3 to 5% among 20 to 30-year-olds in Africa. We don't know why. We think they could be environmental. It could be because you're living past infectious disease. We just don't know why. But this is a problem because we anticipate that 50% of 25 and under are going to be living in Africa by 2050. We also know that by 2050, 2 out of every 5 children born are going to be living in Africa. So are we ready for this? Are we truly ready for this? And most of the times that we're actually seeing cancers in Africa, they're presenting at a late stage setting. And unfortunately, that mortality rate is really high. And I suspect most of you know someone that has had colon cancer. The Black Panther actor, he died of colon cancer, stage 4, in his 30s. And the reality is this is coming to the surface. Now, there are many opportunities of trying to leverage AI in that space of cancer. So for example, in the screening modality place, well, we have endoscopies in the United States, right? Everybody can get an endoscopy or they can get a stool test, sometimes not culturally acceptable. But there's one endoscope for 100,000 Africans here in the African continent. So we need to find additional approaches to trying to do that. So one thing that we postulated likely for the future is to take routinely collected blood that have features in that over time that can help you risk stratify high risk versus low risk, and then send those that most need the colonoscopy for a colonoscopy. Now, some might argue we don't have routinely collected labs, we don't have this longitudinally, but one might argue that we need to start thinking about how to use these routinely collected labs. They're objective, they are routinely available and can be used across the world. I get my hemoglobin drawn here and I grow it in the US, it's likely going to be similar. And it's cheaper. And so one of the opportunities here, and if any of you already have longitudinal lab data in Africa, consider using some of our open source algorithms that can help you better understand how to identify those at high risk for developing cancer. There's a space for generative AI in colorectal cancer screening and treatment. So used in a colonoscopy, these systems have been deployed in the United States, where it'll actually put a bounding box around what it thinks may be a dysplastic area or a polyp area or something that needs to be investigated. But we're actually seeing people getting a little lazier at doing the colonoscopies because they're seeing this bounding box. But don't forget, if you're not looking in a certain region, the bounding box will not appear. So it's really important to have the user involved when you're actually doing these colonoscopies. And the third part, which is computer vision, and I gave a methodological approach that we're using. This is the U01 that's currently funded under the DSI Africa mechanism. And this describes sort of the traditional pathological approach to the detection and diagnosis of colon cancer, knowing that there is a sort of limitation in availability of pathologists, lab systems. And as the depreciation of some currencies are occurring, it's getting even more and more expensive to buy the stains required for you to actually do the histological work, because when you get the tissue, you got to get a courier to take it to a lab. It's reviewed under a microscope. You got to use all those stains, you get the diagnosis, and then you get the treatment. And what we're proposing in this new U01 is that you have the tissue, you can actually take a digital picture, a low pixelated picture, even with an iPhone or an Android, actually upload it into a cloud-based system where it'll run the algorithm and give you a diagnosis in conjunction with the pathologist. The process is faster, more efficient, less costly, but again, something that we want to evaluate in this U01. And the way it works is that, imagine in slide A, you have an example of a colonic biopsies, and you see these glandular round structures, and then the tissue in between. What these sort of masks on AI do is actually give you the area of the gland as well as the cancers in sort of the panel B. In panel C is everything in between. But when you do the subtraction, it actually gives you an evaluation of where the cancer is and what the potential risk of that cancer is for the future. So I hope this makes sense. And I know I'm going a little bit fast to catch up on time, but please slow me down. I guess we have questions later. I'm happy to answer those. But I think everybody has also talked a lot about having a multidisciplinary team. You know, the worst part of this, and I have been susceptible to this, is building an algorithm that nobody uses, right? So what you need to do is make sure that what I'm going to call not stakeholder engagement, but sort of your community alignment group, folks that are your pathologists, your surgeons, the workflow folks are all involved in sort of the development and conceptualization of use of this work. And so we have Aga Khan University, who are our Ozima partners, Tenwick Hospital, which is a more rural, remote area where we were going to use this, our trial site. And actually, they provided the first exemplars of the risk of colon cancer in Africa, and sort of our supporting University of Michigan team. So transitioning away from cancer, but remember, in the cancer space, this could be applied to almost anything. But here we're going to talk about AI opportunities for community-based health data. In sort of this mechanism, you could use generative AI not only to develop questionnaires. Sometimes questionnaires have redundant information. You have male, and then are you pregnant? Doesn't apply. Things like that. But then also volume of information that it can analyze. You heard a lot about synthetic data generation and some of the adversarial networks that can be used to do that. So we won't talk too much about that. But on the treatment side, we've used reinforcement learning to actually help deliver cognitive behavioral therapy to remote areas where mental health resources are unavailable. So again, a huge breadth of way, but there is a potential for AI. Switching to privacy and security, as you can tell, I'm just giving you examples in these different domains. But how do you decode GPS data, right? Which is now becoming more PHI data. And so you can do some random noise injection, perturbation of the data that's can be used through AI. Personal data where you're sort of scrubbing, ID or certain pertinent things within notes using BERT and long form methodological approaches. And then federated learning is actually an AI approach where you actually build the algorithms separately and then share them more centrally and then weight them differentially on the population that you're actually trying to serve. So getting to trust and bias using AI. And I'm going to see if I can make this more interactive in a second here. So this is a recently funded grant by the Bill and Melinda Gates. And I'm selfishly borrowing off my colleagues here. Anthony Ngugi is here from the AKU. And Jeffrey Sivo is at the University of Michigan. And they just got funded around using demographic surveillance data to generate causal inference or association, and then how to embed them within large language models. And I'll walk you through this in a second here. So imagine you have demographic surveillance data, and you have all these sort of elements on surveys that you've captured. You can actually identify patterns within that data. But what's really interesting here is, can you actually make causal inference? And some might argue that observational data cannot be used for causal inference, but there are approaches that we're trying to use within AI to do such. And then when you identify that truth or that odds ratio or that predictability, can you combine it with large language models in order to give you better information that your community members, your policymakers, your first line providers can actually use for meaningful information? So do we trust AI? So how many of all of you actually use ChatGPT? Okay, so a good number, maybe 50%. How many of you trust ChatGPT and would use the information in ChatGPT? And don't lie, I know you've all used ChatGPT. So how many of you trust ChatGPT and have actually used it? Okay, I believe them. Okay, so I'm going to walk you through an example with ChatGPT. And this was actually an example by my colleague, Ewart Steiberg, that he presented, but I actually didn't believe him, so went and did it myself and tried to figure this out. So I'm asking it, can you help me with a calculation? By the way, ChatGPT is very, very polite. Of course, please provide the details of the calculation you will need help with, and I'll do my best to assist you. Okay, so what is the product of, I gave 3 random 5-digit numbers. And it says the product is, that number there, 24207842444. Unfortunately, that number is wrong. Okay? That answer may be wrong, is my response to it. Let's try again. So it does the calculation again. It says, again, very politely, you're right. My apologies for the oversight. Thank you for pointing it out. The correct answer is unfortunately another wrong number. Okay? Let's try once more, okay? Are you sure? I apologize for the confusion earlier. Let's calculate it again. And it's telling me this time I'm confident in the answer. Unfortunately, it's still wrong. Okay, so I encourage you all to kind of look at it. Now, in all fairness, this is a large language model. It's not a calculator, but you wonder why I didn't build a calculator in there. But just food for thought, okay? So how could this potentially be used in research? We talked about having, the community alignment group ask a question. In this case, I simulated sort of this questionnaire to ChatGPT, and I know it's a little bit small there, but what I was going to say is, what is the rate of low birth among pregnant women in sub-Saharan Africa that have had malaria? I'm trying to do it in one sentence because it can get pretty polite. And it says, as of my updated January 2022 algorithms, it says that it's anywhere between 5 and 23%. So another good thing about ChatGPT is it's very good at guessing, as you can tell. But it's not, that range is quite large, right? So 5 to 23%. How would I actually utilize that information? So I said, well, what I know from some of the HWO work is that there was 11 million pregnant women in sub-Saharan Africa infected with malaria, and about 900,000 children were born with low birth weight, based on a 2019 report. So could you help me if I gave you that information? And interestingly, again, very concisely, it used that information. And actually, this time, the calculation is correct. It's about 8.18%, between that 5 and 23%. So a little bit more specific there. And then I said, help me communicate this effectively to the community. Now, this is where it's also very good at, right? So it said, hey, in 2019, for every 100 pregnant women in sub-Saharan Africa infected with malaria, 8 delivered babies had low birth weight, emphasizing an urgent and need for preventative interventions. So very polite, very good guesser, very good at translating information, but be careful when using some of these technologies. So biases in artificial intelligence, this is something that we did on DALL-E, where I asked just, can you help me show me how artificial intelligence is helping care for a human? And what it did on the left was a simulated picture of a person, mostly Caucasian. And then I said, can you help simulate a human taking care of a human? Much better figure, much more empathetic. So again, knowing how to use this and why you're using this is going to be extremely, extremely important. Another example of potential bias in artificial intelligence. So as most of you know, during COVID, there was an encouragement of using a pulse oximeter to actually look at oxygenation levels, and the FDA, our federal device government, had approved this. And of course, if you have your blood oxygen level or your pulse ox level less than 89%, they would encourage you to use oxygen, right? Well, what they found at the University of Michigan, this was a New England paper in 2020, was among critically ill patients in the ICU, about 12% of Black patients had a normal pulse ox, but was actually oxygen deprived and were not getting oxygen, compared to like 3% of the white population. This was then substantiated in children. It was then substantiated in Veterans Affairs. And what I'm just trying to point out here is that as we do technological advancements, we need to be clear about sort of the regulation about this, and algorithms and potentially machine learning and decision support systems are going to get regulated. And so just to be thoughtful of how we develop these new technologies. So I think I'm on time. So in summary, artificial intelligence and generative AI have an enormous potential for improving health in Africa. There exist opportunities across a broad spectrum of things, but I encourage you to think about cancer space and the community-based health data space. EHR is not quite ready for prime time, but is an emerging thing that you should be thinking about. AI can be used to ensure privacy and data security. Trust and bias in AI must be addressed. Again, thank you so much.
Thank you so much, Dr. Waldy. Excellent talk, very engaging. It's my pleasure to introduce Dr. Henry Mwambi. He will be our next speaker. He's a professor of statistics at the University of KwaZulu-Natal School of Mathematics and Computer Science. Extensive teaching record at both undergraduate and postgraduate level. Research on statistical methodological development and applications in health and other biological fields, including modeling infectious disease dynamics and applied statistics in general. Supervised and co-supervised master's and doctoral students from a number of countries in sub-Saharan Africa with a goal to enhance capacity in biostatistics. He is the guy of the Sub-Saharan Africa Consortium for Advanced Biostatistics Training and for the DSI Africa Research Training Program, harnessing data science for priorities in Africa. Dr. Mwambi, thank you for joining us.
Thank you very much. Thank you for the organizers inviting me to come and give this talk here. Thank you for our Rwandan colleague for welcoming us in this beautiful city of Kigali. So as you've been told, I'm from the University of KwaZulu-Natal. I'm one of the MPIs for harnessing data science for global health priorities in Africa. And what I'm going to do today is basically to take you through some of the initiatives we have been having in UKZN to enhance capacity in health. So the outline is brief, just a background on this training program. The series of short courses we've been carrying out, and they are basically methodological and also domain area short courses. And the domain areas which we are interested in are two: climate change, food systems and remote sensing, and health system strengthening. Background, as I've just said, we are interested in harnessing data science for global health priorities in Africa. We baptized ourselves as Washatakim, Swahili meaning ignite data. So working on applications for data science and health in Africa. So this is a collaborative project between Harvard School of Public Health, Heidelberg Institute of Global Health, and 4 partners within Sub-Saharan Africa, University of Ibadan in Nigeria, Muhimbili University in Tanzania, Makerere University in Uganda, and the University of Ghana in Ghana. So basically, the overall goal of the project is to develop advanced data skill researchers in health data science in Africa through a rigorous curriculum and set of training and research activities designed to address the health needs of Africa countries. So this is basically the brief background. So as a whole, we are composed of a multidisciplinary team of researchers and expert faculty with in-depth experience in data science and the following global health priorities, that is health system strengthening and food systems, climate change, and planetary health. So our core principles in the training approach is actually is competency-based, mastery-oriented, application online enhanced. This online enhancing is important because when we were actually carrying out these short courses, we aimed at having them as in-person, but we realized that we needed to incorporate a component of online attendance for those who could not make it because of some reason or the other. So in terms of the structure, we have an executive committee composed of the PIs, training directors, and co-opted members with vast experience in the areas we're interested in. We have also got a training advisory committee to help us advise on how we are progressing. So the first methodological course we thought about was actually statistical computing in R. But after a while, we realized that not all the participants are fully versed with basics in R. Therefore, we started with a boot camp in R. So this boot camp in R was basically aimed at to introduce participants in to basics of R and also some aspects of Python programming, language data types, techniques for manipulation of data, and how to implement fundamental program tasks. This bootcamp also covered version control and reproducibility via Git and GitHub, how to clean, visualize, and analyze data in a reproducible way, and also take them through some foundations of statistical computing, programming, and data science. Then the statistical computing R itself covered the following key topics: how to conduct data wrangling and cleaning to construct an informative manageable data set, how to organize data analysis and make these analyses shareable, reproducible, how to perform exploratory data analysis to generate hypotheses and intuition about the data. This is very important, to explore the data in order to generate hypotheses that make meaningful sense. How to communicate results through visualization, brief reports, and interpretable summaries. So you can see clearly, because of the online component, we had 22 in-person participants and 3 virtual. So we actually took care of both aspects. And then the second course we thought about after the statistical computing in R, in order to enhance health data science, is actually machine learning. So we had actually opted to have 2 courses in machine learning, but because of some constraints, we decided to combine them into one and call it machine learning 1 and 2. So this was a 2-week short course taught by several experts, both locally within UKZN and also internationally, particularly from the Heidelberg Institute of Global Health. The course aimed to enhance capacity in machine learning, methods for health data science to address global health problems in Africa. So we structured it in 2 weeks. So week 1 was basically to introduce the participants into the machine learning methods and techniques. This was comprised of lectures and practical exercises involving computer application using relevant and data sets in the health domain. Then week 2 was a bit advanced. So this covered specific case study applications using data sets of interest, either from place of work or data which was shared by the instructors, because some of the participants came with their own data sets which they wanted to use machine learning to understand. So this week 2 actually was actually involved advanced machine learning methods, but still emphasizing the ideas covered in week 1, right? So that was basically to the structure of the course. So you can see clearly the key topics we have covered under machine learning was the intro to machine learning, as you know, introduced notation, terminologies, and performance metrics, okay? And then the machine learning methods which were covered were supervised ML models, that is logistic regression, naive Bayes, k-nearest neighbor, support vector machine, linear and quadratic discriminant analysis, how to differentiate between regression and classification trees. This is important because we have statistical approaches and the machine learning approaches. So we made sure that we make sure that students can actually merge the two quite well. So, and how to use random forest techniques to classify data. And then we also went to an advanced level to deal with classification and regularization techniques in modeling health data. In particular here, we took the participants through the use of support vector machine, multinomial logistic regression, and regularization techniques in modeling multi-class health data. So it was very important that we also emphasize appropriate statistical model comparison techniques, interpretation of machine learning results, and also how to write brief reports on them, because it is important that once you take through your data through the machine learning algorithms, you should be able to write nice reports about them. Then these method courses were actually increasing in complexity. So the third course which you offered was deep learning, which is a subfield of machine learning that builds predictive models using large artificial neural networks, as you have heard from the previous speakers who are experts in the area. So basically what we wanted to cover in this is basically basic concepts of deep neural networks, discuss basic neural networks, convolutional neural networks, and recurrent neural network structures, and implement them to biomedical and public health data. So we also structured it in 2 weeks. So week 1 was DL methods and techniques through lectures and practical exercises involving computer applications using relevant data sets in the health domain. In week 2, it's an advanced level, advanced DL techniques with real-life applications in public health. And this was done in groups so that they can share ideas. Remember that our participants were composed of both those from the health side and from the statistics computing side. And we mix them together so that they can share experiences and how to actually interact with each other. So you will see that the key topics which were covered here, as I said, intro to DL, notations, terminologies, performance metrics, neural networks, architecture, multi-layer perceptrons, backpropagation, and regularization techniques. Then we took them through convolution neural networks, models, and application to public health domain. We also introduced the participants to recurrent neural network models and their applications to climate and time series health data. Then they were introduced to transformers and transfer learning and model building in health data. And then appropriate statistical model comparison techniques were also covered, interpretation of results, and also to write short reports on the results which you actually derive from those models. That was very important, and actually it was very engaging. Then we transited to domain area courses. So the first domain area course, which was actually we actually delivered, was on climate change, food systems, and remote sensing. So what was the aim here? The aim was basically to concepts of climate change, nutrition, diet, food systems, remote sensing, and plan of these, and linking the concept. And part 2, that is 2 weeks. So part 1 basically dwelt on concepts of remote sensing and spatial analysis concerning food systems and climate change. And then part 2 was intro to concepts and indicators of food systems, climate change, and planet health. Practical solutions for climate change adaptations and mitigation in intervention projects. So what were the key topics covered here? First, we took them through the history and introduction of remote sensing. That means introducing them to concepts and indicators of climate change and weather, environmental footprints of food, food systems, nutritional status, and dietary behaviors. Then they were taken through satellite pre-imaging processing, supervised and unsupervised image classification, methodological challenges and solutions. They were taken through GIS techniques, spatial analysis, and then how to drive solutions for climate change adaptation and mitigation. You can see clearly here, we had 12 in-person participants and between 6 to 12 online, because when people are participating online, you'll see that some will consistently be there, but some will drop out. So that is a challenge which we need to check when we go forward. And then finally, we had the second and final domain area, short course, health systems. What was the aim? To introduce concepts of health systems and its application to health data science. So basically linking these concepts and analysis of data, exposure of analyzing health data using machine learning techniques. So what was covered here? So this is a domain area. So introduction to health systems concepts, introduction to attributes of health systems, the role of leadership and governance, and the potential of health system strengthening. Introduction to health system building blocks, services, and finance. Identify what is needed for improving the performance of health systems. And then finally, from the machine learning side, application of machine learning to health systems data, including clustering and classification. So this was our second domain area short course. And you can see we had the 16 participants in person and 24 online. So what is the summary? So what we have realized or what we have learned is that the short courses helped to advance a community of health data scientists in Africa, because the participants came from across the region, sub-Saharan Africa region. The short course participants are actually currently actively involved in the use of the method they learned in their home countries and places of work. The courses were highly interactive between participants themselves and the instructors. So what we aim is that in 2024, the short courses will be repeated with possible modification given what we have learned from the first round of offering. And then finally, as a hub, we are eventually going to launch a master's in health data science in 2026. The modules are already in progress, almost in the final stages. And what we have learned is that these short courses have helped us to inform the creation of this master's in health data science. So that is a very good exercise which we undertook. So finally, I just want to thank the team of instructors, which were both locally and internationally, particularly from the Harvard School of Public Health, Heidelberg Institute of Global Health, London School of Hygiene and Tropical Medicine, African Health Research Institute, and others. Several teams were involved in making this possible: the PI team, training program directors, program coordinators, the spoke partners in Ghana, Nigeria, Tanzania, Uganda, and the other fourth one. DSI postdocs, we have already got 2 postdocs who are about 6 months to complete their the first cohort. This is Mohamed Mohammed and Gabriel Kaladagadu from Ghana. They were involved in teaching the courses. So we have just recruited the second cohort of postdocs, 3 of them, who are starting in 2024. We also worked with the Center for Rural Health administrative team, which helped in coordinating all the logistics, the UKZN College of Health Sciences and College of Agriculture and Health and Engineering Sciences. And then we also thank the NIH for the financial support, because without that, this would not have been possible. I also want to thank the advisory committee members, the mentors involved in the program, and the DSI consortium as a whole. Thank you very much.
Thank you so much, Dr. Mwambi. That was really inspiring and really exciting to see that cohort of capacity and people coming out of that program. It kind of relates to what I spoke about yesterday of building the human resources behind all of this. So thank you. It's my pleasure now to introduce Dr. Chen-Feng Chiong. Dr. Chiong is an assistant professor in the Department of Civil and Environmental Engineering at Villanova University. And it's interesting change in tack here. Dr. Chiong's research is focused on the analysis, modeling, and simulation of human mobility and travel behavior, and its wide applications in public health, economics, sustainability, and the environment. So Dr. Chiong is going to be talking to us about a multidisciplinary approach, integrating human mobility, health, and climatic data with AI, ML, and big data techniques. Ah, there you are, hiding on the side. Thank you. Welcome.
Let's try the clicker. Perfect. Good morning, everyone. Thank you. Well, the previous speakers have set a perfect stage for me to speak on things we're working on. As an engineer, as a modeler and user of AI and advanced modeling techniques, I'm definitely one of the gardeners. It's my great pleasure also representing all our gardeners on our Inform Africa team, talking about our soil, our seed and plants, and hopefully we can talk to other gardeners and generate some new ideas, new plants, new seeds we can use in our adventure in the next 2 years or so. So let me first talk about our overall goal and specific aims of Inform Africa. Well, in short, we're working on 4 aspects: data streams, that's aim 1, and also our soil. We're generating interesting data sources, such as the mobility data I'm talking about in a few slides later, and also genomics data, vulnerability, social vulnerability index that all the other projects, cores, and industrial partners are working on. They are all exciting new information that can be leveraged by others. Okay. Secondly, we are also developing different tools. You will see engineering tools that we're working on, geospatial tools that colleagues are developing. So all of these are also shareable knowledge to be transferred to elsewhere. Okay. Number 3, it's the collaboration. That's about growing our Gartner team. We have pilot projects, bringing new PIs. We have a training program, pilot program that we are also developing, transferring our different knowledges as well. Then finally, engaging government closely regarding policymakers and those stakeholders that are closely engaged. So we're making all progress on these different 4 fronts. And specifically, our project number 2, that's the project that I'm leading, and will be one of the focus for today's talk. Overall, we are working on human mobility data. You may wonder what that is. Well, it's a different type of soil we're working on, but you will see what that is very shortly. Then we try to use mobility data to analyze policy effectiveness. So that's about those non-pharmaceutical interventions, mask mandate, and so on and so forth. How would those policies we implemented during COVID really influenced human behavior, human mobility? Did people respond effectively? Did the policy take effect in mitigating a number of cases? We have various models, studies doing that across different projects under Inform. Then last but not least, that's something we're currently working on, really is looking to the future. We are learning from the past pandemic. Right now, it's in a manageable status, but we're pretty much trying to prepare ourselves for the future. Maybe the next pandemic, maybe another infectious diseases that we've never seen before. How we can use mobility patterns, model them using pattern recognition, AI models, and really be able to predict a lot of the what-if scenarios. So that's really the fundamental aim 3 that we're trying to address, and also highlighted in the slides. Okay, so you may have been curious already what the human mobility data look like. So I'm throwing you the slides immediately. On your right-hand side, you see that the formality of our raw data. Essentially, it's data points, location points generated from smartphones, Wi-Fi usages, Bluetooth, pinning, so on and so forth. Even if you're driving, your vehicle might also generate a lots of GPS data points, connected vehicle data. So we're sourcing all of these data points, and through AI and big data technology, we are learning what are the travel patterns, how many people are traveling from Cape Town to Johannesburg in South Africa, how many people are traveling within Cape Town, are they traveling to grocery shopping? Did they spend 1 hour, 2 hours shopping? Or they just quickly grabbed a coffee and go? So we are quantifying all of those human mobility patterns, activity patterns, trying to understand, how during the pandemic, human mobility has been changed, adapted themselves, and formed the mobility pattern nowadays. Right? We all know that there are various patterns being formed, examples being flexible work schedule. Sometimes we can work from home. For most of us, that's not happening before pandemic, right? Then people are driving longer distance. That's in the United States. We are used to travel longer using our own cars now. So all of these patterns becomes the study soil of our research. And we try to quantify using the policy and effectiveness as our key research question to answer. Through that, we are also analyzing what you see in the chart in this slides. Mobility has been dropping, shown by the blue curve, but also we tie in various policy decision-making points. That's the those thin solid line and the vertical dimension, highlighting the x-axis being the time. We're highlighting when did the non-pharmaceutical interventions come into place, right? And analyze the effectiveness of those policies. And the finding really is that those policies are coming into place a little bit lag behind. Okay? So we are already making a lot of the adaptations ourselves. Being so autonomous human behavior, we're avoiding the risks of the pandemic automatically, but without really being forced by any policy interventions. That could be one lesson learned from the past pandemic, helping us to support the decision-making, especially from the DOT perspective. How should that policy be designed more effectively could be a question we help answer. Well, there are another two busy graph I'm showing. I can quickly fly through them. Another big takeaway point is we can also quantify the different contributing factor from the human mobility to the disease transmissions. Because of the data, high fidelity data, we are really quantifying different types of travel, including cross-province, long-distance travel. That's the cross-border, cross-province border, even cross-nation border travel. And also we can quantify the travel within the district, within the city, even within the community. How would these different type of travel contribute to the pandemic? The effectiveness is shown in the highlighted blue curve, and its bandwidth shows the coefficient estimated error range. Basically, we're showing that they behave so differently. The cross-province travel really contribute to the pandemic at the very beginning. So that's when we do not know what's really going on. A lot of travel is still going when disease is already among us. And at that time, cross-border, cross-province travel contributed a lot. But once the travel has been mitigated, we know that we are limiting our flight attendance, limiting the bus services, and all those limitations came into play, and we see a dramatically decreasing effect from the human mobility of cross provinces to the pandemic. While that's not the case for the local travelers. Within the district, we see a strong, significant contribution during the first couple months in the pandemic. That's not even reduced when people know it's the pandemic, and it's not even reduced when those travel bans, federal lockdown policies were into place. So that's a huge finding. Some ways that we can target community transmissions, how we can design the policy effectively for these within district travelers could be a topic to study. Okay, but we do see that this effect got diminished once, that's probably because mask mandate are more accepted by people. so that even we still have a strong and steady within district travel. The effectiveness from those travel to the pandemic becomes less dramatic. All right, don't want to bother you with too many technical details, but I'm happy to share papers with you. We have been working on publications. As a matter of fact, there are many good ones that's been already in the in the press already. So I'm happy to share more with you offline. But we're also trying to look into climate change. So that's really related to what Henry was mentioning earlier as well, but more from an engineering perspective. So we started with looking into extreme weather events like flooding in Nigeria. We will be looking at other extreme weather events like hurricane, excessive high temperature, low temperature, droughts, and so on and so forth. Really trying to leverage what civil engineering, environmental engineering approach could help. So we started with annual flooding overlook data and trying to supplement that database with additional engineering data sources that we could leverage possibly. So this is another data source we're bringing into play, the remote sensing data from satellite image based on Sentinel-1, which is a European Space Agency satellite mission, providing day and night imagery. So we're sensing the flooding areas using water reflectance from the satellite signals. So that way we can really quantify from time to time, how would the flood area evolve within Nigeria? Yeah, so this animation showcases the dynamics of the flooding using the red colored area. This really enables us to link the flood data accurately with our mobility data shown in the green color in these two graphs. So trying to integrate these two data sources, we can quantify that mobility does decrease during the flooding period. We're comparing before flooding using the top right corner figure versus the human behavior, human mobility during the flooding period in the top, in the lower right corner. So that way we are showcasing that a lot of the areas with a lot of mobility, for instance, in Ogun area, Lagos, downtown area, human mobility decreases. But what's more importantly is that satellite image can only give us snapshots, right? It orbits with 6 days time difference, time period. But mobility data is sensed every single moment. We're observing human mobility day by day. That can really supplement our understanding and provide even more accurate estimates on the flooding period. When does flood come and when did the flood end? And use that, we can pinpoint that fairly accurately. Great. Summarizing what human mobility data sources and things we could do. The question we want to keep asking ourselves is, can we do more? Right? We're working on various directions. Essentially, we can have human activity, travels, traffic data, and also greenhouse gas emissions and EV mobility data from vehicles. And all of these contributes to different fronts that our DSI big family is working on. We are working on epidemiology, pandemic tracking and prediction, but I'm aware of that there are colleagues working on shock trauma triage and health rehabilitation of the vehicle crashes and so on and so forth. So those thrusts can be also supplemented with travel data and traffic data that we have. Then finally, environmental, climate, and health topics that's shown in the darker green box on the lower right corner can be implemented through a collaboration with vehicle emissions, so on and so forth. Just want to quickly throw an idea that we have done before and trying to brainstorm as we are talking about in this theme, talking about opportunities, right? So what we have done before is we tried to link transportation data with trauma registry. This is the data residing in the engineering domain. We know the vehicle crash records from our emergency response team. We know it's happening on March the 2nd, 2016 at this time, and it's a type of pedestrian crash. And we have linked that crash records with the roadway traffic. How fast are vehicle moving at that time? Then what's the volume of the roadway? Is it crowded? Is it less crowded? Then finally, we're trying to see if this traffic information could help us with better decision-making in terms of shock trauma triage. So what we ended up doing is a AI model of decision tree and random forest that was demonstrated to have superior prediction capability accuracy in helping us making that trauma triage on site. So we all know that decision has to be made timely and accurately. And this model certainly demonstrates potential and value. But we have done this in the US. Things yet to be done, including address the special data characteristics in Africa. The data might be coarse. Traffic data might need some twist and calibration. Then can we also integrate patient data? We've been just doing crash versus the traffic, but crash data can be linked to inpatient, outpatient record, or even longer term health outcomes of the patients. So that could be something we do through a cross-hub collaborative research, for instance, between Inform and our design colleagues. All right, I'm running out of time. Just want to acknowledge it's not just my work, it's the collaborative work done by our 3 projects, cores, and also our industrial partner. I want to acknowledge our sponsors, then all my colleagues from IHVN, University of Maryland, Baltimore, Villanova University, Caprisa, Stellenbosch University, and ACROSS. And we also have our PI from project number 3, moved to Monash University, Australia recently. So it's a global team, and we're looking forward to having more colleagues, collaborators across the entire DSI Africa and beyond. All right, thank you so much.
Thanks, Dr. Chong. Yeah, that was fascinating. A whole new world of different types of data. So different soil, different seeds, and more gardeners. So it's excellent. Thank you. I have a lot of questions, which I'll pick up later. Right, our next speaker is Dr. Rahel Bekele, who's currently an associate professor at the School of Information Science in Addis Ababa University. I'm fascinated in her bio. She worked on machine learning techniques to make predictive models on student behavior. In my experience, student behavior is very unpredictable. So I'm looking forward to hear what she says, though I know her talk is not on that. So she's also played a major role in facilitating the establishment of MSc in Health Informatics, curriculum design, administration of the first joint program of the School of Public Health. So I invite her to the stage. Thank you.
Thank you for the nice introduction. I'm a little bit nervous to present in front of a large crowd like here. So can you clap for me instead of later? Okay, thank you. My name is Rahel. I'm from the AfriADST project, advancing public health research through data science, through data science training in Eastern Africa. So my presentation actually are the basics, because we're now back to sub-Saharan Africa. So it will not be as sophisticated as my previous speakers. So we'll just tell you our experience on working. This is a partnership project among Columbia University, Addis Ababa University, and Nairobi University. We have all the PIs here, and the principal contact is Professor Kiros Brhane from Columbia University. He's here also, and he's the boss, actually. So from Columbia University, we have the Mailman School of Public Health, the Lamort Dohort Earth Observatory, Data Science Institute, Department of Statistics, and School of Engineering. And also from Addis Ababa University, we have various schools from School of Information Science, where the project is a host, and we have School of Public Health and Department of Statistics. Same from Nairobi University. We have the School of Mathematics, School of Public Health, and also School of Computing. And we have the Training Advisory Committee, and also stakeholders included, incorporating government, non-government institutions, and also various projects. So the initiation, we have been saying a lot about the initiation. So I'll just summarize it into 3 things. There are a huge volume of data produced almost every day, every month in Africa, but we only see a small part of the results. So various public health intervention programs in the country do not contribute much because we don't see the hidden patterns in the data. So there is a huge need for data science, machine learning programs so that we can see what we are missing, so that the intervention programs are not working as expected as we could. So this brings us to data science. And then we have severe lack of well-trained data scientists, and there are no homegrown educational programs. That also works for Kenya, not only for Ethiopia. And then there are no collaboration between researchers in the field and also stakeholders who are actually owning the data. And this is because of the ethical data partnership agreements that we have. So these are the project initiations. And actually we have 5 aims. One is building the MSc program in public health data science, both in Kenya and Ethiopia. And then we have a short-term training programs, faculty development, because we actually need teachers after establishing the master's program. And we aim for research immersion, where our students also work with existing research programs. And then at the end of the 5 years, we have a plan for possible extension to PhD programs. So we benefited a lot from the collaboration that we have with Columbia, especially because we are trying to find the best approach for shaping the curriculum, and then also identifying relevant topics that would have greater impacts, because the local contexts, both in Kenya and Ethiopia, are different. And then we have identified it. The collaboration actually helped us to identify the potential candidates for the program, and then which are the most conducive environments to deliver the program, and also short-term topics. So we did a lot of things even before starting the program. The needs assessment and the stakeholder engagement were the ones which formed the curriculum design and development. And we had various capacity building training programs, both short-term and also faculty scholar visits. We have also formed research groups, which I will say in a moment. And we have produced various supporting documents. We actually consider it as a model program for Addis Ababa University also, because we have introduced internship programs, research groups and the like, which have not been existent before in other MSc programs. So the project was officially launched in Ethiopia in March 2022. And the university management actually applauded the program and wanted us to start last year, but that was not the project structure. Kenya was supposed to start last year, and we actually started the program this year. And we also had an official launch in Kenya in April 2022, where we were also received by the Vice Chancellor. So it shows us in both the universities, university management is supportive of the program. So these are some of the highlights that we did in the needs assessment summary. For instance, we tried to understand what are the desired level of skills and data proficiency. So the big data analytics, version control, and collaborative coding, which might seem very basic for some of the countries. This was actually something that was important in the country because of the lack of basic trainings in data science topics. So building and using data warehouses, undertaking pre-processing of structured and unstructured data. These were some of the topics that we tried to include also in the curriculum design. We also had some short-term training identification, both in Kenya and Ethiopia. One of the most important things that we have done is stakeholder engagement in both countries. We have now the Ministry of Health, the Central Statistical Agency, the Ethiopian Public Health Institute, the ICAP Colombia also in Kenya are them as major partners because they own a lot of data. There is also the Joy Health Hub in environmental health, which is actually funded by NIH, and Professor Kiros is also the PI for that project also. So there is a PMA project, which is funded by Melinda Gates Foundation. So we have a lot of data that we can also use. So the curriculum was validated in both countries, and we developed actually a harmonized curriculum, and the Colombia partners had a lot of input in shaping up the curriculum. So of course there are small differences between Kenya and Ethiopia. So in the first semester they will be introduced to the basics of public health, biostatistics, and also statistical computing. And in the second year, they will go a little bit, the second semester, they will go a little bit up deeper into probability and statistical inference, machine learning, and then public health data engineering. And internship is mandatory because we expect them to learn from the data, either from the institutions that they come from, but also from the collaboration that we are going to enter with the various institutions. And then in year 2, semester 1, there will be other advanced programs on courses on advanced data analytics and biostatistical methods, and they will be expected to work on thesis. So we've been part of the DSI Consortium meeting last year, where we learned a lot, both in shaping up our research groups and also in taking some of the topics that could be introduced for our students. And we presented a data warehouse architecture research group during the DSI Africa Consortium meeting. So we had short-term trainings. We also benefited from the SHARP training program at Columbia, where we took machine learning courses, various learning algorithms, and even it went as basic as learning about SQL. The other thing that we have done, which benefited both Kenya and Ethiopia, is the faculty cohort scholars visit in the US. So we had mentors from Colombia, so 4 from Kenya and 4 from Ethiopia have already benefited from this faculty scholars visit program. And these are the ones actually teaching in the programs. So we have formed research groups. Unlike other programs, we expect all the students to join the research groups, so that they will not be out there searching for topics. Rather, they will have topics, they will have supervision and a constant work, so that the students will not be lost in between. And again, from the DSI meeting here and also from our works, we have benefited a lot in forming up the research groups, and the research groups also come up with short-term training topics that they need for the work. So what we have actually is in AAU, we have 4 research groups, data warehouse architecture, because there are various data everywhere and from every format. And then there is a maternal and child health research group, communicable and non-communicable diseases, and environmental health. So actually the idea is to bring in IT specialists, statistics, and also stakeholders within the various research groups. In Kenya, we have the statistical and predictive modeling research group, machine learning and data visualization, big data analytics, data security, privacy, and so on. So we are trying to actually work together so that one benefits from the other group, and the Columbia partners will also be part of or member of the research groups. So the current status, Kenya registered its first and second cohort of MSc students. As I said, it started last year. We just had accepted the first cohort. We had overwhelming applications, about more than 300 applicants for only 30 places that we had. So we accepted our 30 students, and with Kenya, they have embarked the research immersion programs. And actually, the admission criteria that we have is IT, statistics, and public health. So we give them bridge courses for 2 weeks so that they come together and they will not be lost when they take courses. So these are some of the students that you see. The upper one is from Kenya and the lower one is from Ethiopia. So ongoing work, or our future work, is continuing teaching the regular program, and we expect also guest lecturers. This is also a benefit of becoming the consortium member. So we expect a lot of guest lectures and other things to bring the students on board, because they are very eager and very, they are very eager to learn. So the other thing is strengthening our collaboration between Ethiopia and Kenya. The opportunity that we have is working relationship with our stakeholders, but maybe I would like to stress the challenge is the need for high computing server, the need for open source platforms. So maybe the Elwazi platform and other discussions that we have here may help us. And one of the opportunities is also becoming member of the DSI, because we are trying to establish collaboration. So the lessons learned, higher education in sub-Saharan Africa is full of bureaucracies. So we both had a problem, both in Kenya and Ethiopia, establishing the master's program. But here we are now, the MSc program is opened, and we plan to sustain the existing initiatives by also having the PhD program, and also establishing a pure or a general data science master's program with public health track maybe in the future. So this is all I have. Thank you very much for the attention. Thank you for the second clap.
Excellent, excellent job. Thank you so much. So we'll move on to our next speaker, Dr. Joyce Nakatamba Nabende. She's a lecturer at the Department of Computer Science and heads the Makerere and Artificial Intelligence Lab, and which is a research lab in the Department of Computer Science. She is a board member of Data Science Africa, and her research interests are machine learning, natural language processing, and responsible AI. And I'd like to apply Rahel's example of a warm welcome, and maybe we can welcome Dr. Nabende to the stage with a round of applause.
Good morning. Good morning. All right, thanks. Thanks again. Thanks to the Coordinating Center for inviting us and inviting our project to be part of this panel this morning. I'm going to speak on behalf of our Mark Data Training Program that is leveraging machine learning and AI to strengthen evidence-based health innovation, intervention, and policy in Uganda. So the aim of our program is to develop health sciences graduates and scientists at Makerere University who can harness data science for health discovery and innovation. Our program consists of partners from Uganda, Makerere University, and some members are here as part of this meeting today. Professor Katete, our PI, Dr. Jivonika is also here, and I think Dr. Charles Pate, the project manager. The partners in the US, we have Johns Hopkins University, where we have Professor William Checkley, who's also part of the MPI team. And because of our previous collaborations from the College of Health Sciences, we also have new partners that have come on board from UCSF. And we have several of the members there who have also been very helpful in the trainee program that we are running. So the uniqueness about our program is the thing that everyone has been mentioning, the multidisciplinary approach, such that we have people even from Makerere University. I am from the computer science department, but we're working very closely with people from the health sciences department, such that we can really grow the whole area of health data science. So our focus and objectives are to establish graduate degree trainings, masters and PhD in data science, with particular focus of the diseases that we know are very endemic in our country, a country like Uganda. For example, HIV, TB, malaria, and outbreaks as well. To also provide post-doctoral training to transition into faculty and independent data science research leaders. And the hope is after their postdoctoral training, of course, come back to the college and also help and facilitate the health data science training, and then to train the Makerere College of Health Sciences faculty to enhance their capabilities for data science research and mentorship. We've also had people doing work in health informatics, but we want to elevate that and make sure that the faculty are also equipped in data science, that they can really take on the supervision and the mentorship of the trainees. And then focus on training that's really multi and interdisciplinary to allow for the application of data science to problems that are even beyond the scientific focus that we have in our program. So what have we achieved so far as a training program in leveraging AI? Is we focused, of course, the thing that we drive, and all my previous speakers have talked about, especially for the people who are in dealing with training programs, is you really want to have a curriculum established. But because of all the lengthy process at African universities to establish new curriculum, we leveraged existing curriculum that was the bioinformatics curriculum that came out of a previous NIH-funded H3 Africa program that we modified and added the health data science track that we are currently working with, and I'll share a few details later on in the presentation. We've made progress with this curriculum, and it's currently, I think, at the university level for approval. It has left the College of Health Sciences. Also, as part of our program, we have focused on the PhD trainee and recruitment placement, specifically in leveraging AI and machine learning in our areas of focus. We also have the MSc trainee recruitment. And I'll also speak about a specific study, which we think is interesting to leverage how AI can be used for creating data set, but also for pandemic monitoring for the recently concluded pandemic that we had in our country. So looking at the health data science program, definitely I won't define what all this is. We all know by now that we are really trying to provide an intersection between computer science and drawing from the disciplines of computer science, mathematics, and because we are looking at bioinformatics as the base where we started from, we're also picking out concepts from bioinformatics that we can use to be able to enhance our health data science training program. In particular, these are the courses that speak to the machine learning and the AI aspect of our program, because that's what is, I think, important for us to even equip our students as well to apply machine learning. We've, of course, grounded them in programming, in R and Python. We've also introduced courses around machine learning in biomedicine, then getting into deep learning. We've understood this morning what deep learning is, and then looking at fundamentals of computer vision and biomedical processing. Much of the data that we collect, there's a lot of image data that's being collected in Ugandan health centers and of course African health centers. And so it's very critical that we can equip our trainees in how to deal with the image data that's being collected for diagnosis. As well, NLP, I love NLP, so we have to also talk about natural language processing, because there's a lot of text data that comes out. For example, if you have an image, there's always a report that accompanies that image that the doctors are going to interpret what they find on the images. Can we be able to equip our trainees to come out with automatic report generation? And so NLP is an important thing, especially in the context of African languages as well, which we think is critical. We also talk about ethics. Ethics are important. We talked about ethics bias previously, and so it's important that our trainees are equipped on that. looking at visualization, data analysis, data mining, data privacy and security. And then for the people who might not have mathematics background or have forgotten mathematics, yet it's important for any machine learning program. We also have concepts around applied mathematics and statistics. So that's really a summary, a high-level summary of the program. In terms of the trainees, we have currently 2 PhD trainees that are attached at UCSF that are looking at using machine learning and AI applications in malaria modeling and also HIV. We have 2 more PhDs that are going to start in 2024 as part of the next steps. Because of the approval of the program that's still ongoing, we have already recruited current MSc trainees that are doing different health and computing programs at the university, but ensure that the focus of their research is around using machine learning and AI for health. We have 8 of them. We were privileged to have 2 of them in the poster session. I think they had their presentations yesterday and today. And that word cloud really just summarizes the areas of research that they're working on around drug resistance, tuberculosis, HIV, dynamic sequencing, malaria, also because we have the strong bioinformatics background of our program. So we have this MSc training, and we hope we can be able to recruit more MScs in 2024. So I will take a break away from the training to focus a little bit on a study that we did in the lab, really just to show the power that we can use, or the power that AI has in trying to leverage existing data sources for pandemic monitoring. The previous speaker, I think 2 speakers back, talked about non-pharmaceutical interventions, and that's really what we're trying to focus on. So we know in many of our African settings, as much as we have mobile phones here, not everyone has mobile phones, not everyone has internet coverage. But many of our people have radio. You know, they will go to radio, they will talk about things that are happening in their community, and they'll also expect to be able to get feedback from the government on radio, especially when you have a pandemic and you have lockdown measures, the NPIs that have been imposed by the government. They will sit right next to the radios because they want to understand what's going on. They want to, you know, say things that are happening in their communities. And so we thought that radio is a very rich data source that we can be able to mine and understand. And so part of the work that we have done is to build natural language processing techniques, particularly speech recognition models, to be able to take radio streams, get the valuable data out of radio. Radio is such a difficult speech because unlike here where you have one person talking, in radio, you have people talking over each other, you have background noise, you have music, and it's not that there'll be speech all the time. There'll be football. Africans love football, so there'll be football at certain times. So when you get radio data, you really need to, skim through it and then get the options or the parts of the radio that are valuable for you to really understand where did the community speak, where did the government speak, what are the parts that are important, what were they talking about. So it's such a long process. And then looking at language, when we speak, many times we'll speak in our local languages. So if I'm in Kampala, I will speak in English. At the same time, I might code switch. I might speak in English, speak in Luganda. You know, there's a mixture of things. And so part of the work that we did, one, was to try and obtain the valuable sections of radio that are important for us. Then we went on to build the speech recognition models in English and in Luganda. Then we filtered those, put these on and got the valuable text or the valuable speech that we had. After transcribing this, we get the text. After getting the text, then we can pass that to the human. We can't forget the human in the loop to really verify that what the model gave is actually correct. Then we can have that out on a dashboard to analyze this. And so this is work that we've submitted currently for review. And so what was important for us is that we can be able to use AI, one, to generate data sets. So we can have speech data sets, we can have text data sets that people can be able to pick up and use. Our trainees can be able to pick up and be trained as they are doing, for example, work in NLP. And our speech data sets have been leveraged to build speech recognition models. For example, we have our Luganda models with a performance of 30%, which is very good, especially if you're looking at a low-resourced African language that doesn't have a lot of text that's out there on the internet, for which you have to build from scratch. Since English is high resourced, of course, the performance is much better, which is 4.2%. But we also have the text data sets that have come out of our models that have been leveraged for text mining and sentiment analysis, such that when we have a pandemic, it was actually the Ebola pandemic. If you can see from the word cloud, I hadn't mentioned, it wasn't COVID, it was Ebola. But we picked out, because we had done work previously in COVID, we picked out what we had done and then moved into a new pandemic that we had, a brief pandemic, which was Ebola. And then we were able to see people really mentioning things that were happening to them in the community. They were really worried about the lockdown. They were worried about the government and the policies that they had imposed. They were already worried about knowing that they're going to go back to the COVID pandemic that they had been before, or the things that had happened in COVID were going to come back now that they had the Ebola outbreak. And there were very many sentiments that people expressed. And we think that these are very good and important aspects to understand and mine from the community that we can feed back to the ministry, or we can feed back to the government. So what we have learned as we are implementing our research program is that for our trainees, because it's really heavily driven by data, we really need to have AI-ready data sets for the PhD and the master's trainee to use for their research. And so we found that this collaboration with the partners from the healthcare domain has been very critical and very important for us to kind of accelerate the process that the trainees require to start their work. So these many partners, some, of course, we inherited them from the H3 Africa Bioinformatics program that we had. For example, the Uganda Central Public Health Lab that deals with a lot of genomic data and sequencing data for different diseases, malaria, HIV, that we've picked out, and our trainees have run with this. We have collaborations with our Uganda Virus Research Institute, with the Infectious Disease Institute that has been doing a lot of work in HIV, modeling and HIV surveillance in the country, Uganda Cancer Institute that has, of course, is in charge of surveillance around cancer in the country. We've gotten a lot of image data there. One of our studies in the lab has been looking at cervical cancer diagnosis and trying to encourage women to come for cancer screening, but we built AI models that automatically are able to take an image, for example, using a mobile phone, and then predict whether the image is cancerous or not. And so we've really leveraged on that through that collaboration. We also have another imaging center called the Ernest Cook Ultrasound Research and Education Institute, where we've obtained data, one on TB. We have a current study where we're actually annotating data for TB diagnosis, breast cancer, prostate cancer, and of course, Uganda's malaria genomics program. So this really has been very instrumental in helping us to obtain the data sets that we need. And then we recently have an NIH grant where we're going to focus now on TB and taking up on the previous work that we had. And we think that from this collaboration, we'll be able to also have more data sets that can be able to help our trainees. And so in conclusion, we've seen that the healthcare organizations and the medical practices that we are working with are evolving from just being adopters of AI models and platforms, but they're really becoming co-innovators with the technology partners in the development of novel AI systems. We have one of our professors from Ecury that we work with. He's a top-notch radiologist, and because he's very busy, we only get to meet with him at 8 p.m. in the night to help us go through our images, to annotate the images, to help us from a computational perspective to understand the things around the images, because we might not necessarily know them, but it's very good, and that partnership is important to him, and he values it and gives it time each and every week to collaboratively be able to work with us as we build our models in the lab. So we are very grateful for people who are picking up and understanding the value of AI and machine learning, even with a healthcare background. So in conclusion, we see that AI can really be leveraged in health data science training programs, and there's really potential to work collaboratively in a multidisciplinary approach to have health data science training on the African continent through joint supervision, but also through the provision of data sets that our trainees can use. Yeah, these are just some pictures of things that are going on in the program. And we are very grateful for the funders, the coordinating center, and the NIH to the funders. So yeah, we are grateful. Thank you.
Great. Thank you so much, Joyce. We have one more speaker and then time for more in-depth questions in our panel discussion. So our last speaker today is Cynthia Changwei Manung. Dr. Manung is a bioethics researcher, and her research focuses on how theories of global health justice and African communitarian ethics could inform the equitable global governance of genomics and health research, as well as the ethics of infectious disease control and management, public engagement for genomics and data science in health, and ethical and social issues related to emerging biotechnologies. Thank you.
Thanks for the introduction and good morning to everyone. So I will just look at the ethics and equity considerations for AI and data science in health research. And so the first, I want to tell you a story, but it's one that you must be familiar with. And I'm sure that most of you in the room, you know Adam, you know Eve, and you know Genesis. But I'm not referring here to the Adam that was there 1,000 years BC. I'm referring to Adam that is 18 years old. And Adam was the first AI robot scientist and was designed to identify the relationship between genes and enzymes in yeast metabolism. So Adam is credited to be the first machine to discover novel scientific knowledge autonomously. Adam discovered the function of locally orphaned enzymes. But what Adam can do is that Adam can initiate over 100 new experiments in a day, and every 20 minutes can automatically record the metadata of the experiments. Adam is fully automated, does not require technicians, except to periodically add laboratory consumables and remove waste. So I'm sure for the postdocs, this is good news for you. If you have Adam in your lab, then you can be sure that you have your Saturdays free, you have the evenings free. So you should encourage your PIs to get Adam. Then there is Eve. I love Eve so much because Eve is very smart. And if you know the biblical Eve, you will know why Eve, the robot scientist, is smart. Eve is only 8 years old, but Eve has made a discovery on her own. Eve has discovered that there is a compound with anti-cancer properties that might also be used to combat malaria. Eve is now planning to help identify new drug candidates that will be cheaper for neglected tropical diseases such as African sleeping sickness, as well as for more widespread diseases like malaria and cancer. So if we want to use AI to address global health inequities, then Eve is doing a perfect job. Eve also, you will remember the biblical Eve. Eve is making sure that she is on top of Adam. So Eve also is recording scientific knowledge very accurately from the time the experiments are conceived to the time it is executed. And so for Eve, I'm sure all the PIs would want to get Eve, because I understand that you've been struggling to get research officers. So perhaps your struggles to identify capacity for your projects, Eve is that solution. And for the research officers, if you're wondering that Eve is about to take your job, perhaps you're saying that your next move will be to develop your capacity in data analysis. I still do not have good news for you, because there is Genesis now. And Genesis's primary focus is big data analysis. And Genesis is able to carry out detailed analysis of how biological function relates to metabolism and active genes. We've all been complaining that we lack data analysts on the continent. Should we go for Genesis? And even if we say that, okay, we are going to get Genesis, then perhaps the scientist in the room will say, okay, we will focus on writing. But we already know that there are many AI tools that could support your writing. They could do the literature review for you. They could even give you a complete manuscript. And it's no news to any one of us here that there's some AI tools are now authors on papers. And some will be corresponding authors. And I can assure you that there will be good corresponding authors because like the first speaker or the second mentioned, they are very polite. So if you reach out to them to ask for a data set, I'm sure they will respond. And if they're unable to give you, they will assure you that they will talk to their university office and will kindly ask you if there is anything else you want them to assist you with. So with all this brilliant work that AI has brought, or biomedical AI has brought to science, why are we worried about ethics and equity? We have seen that it can address global health inequities. We can see that, but perhaps it's the ethical issues. But when this is a word cloud of the ethical issues that people keep on discussing for AI in global health. And my question is, are these any different from the ethical issues that we've discussed over the past years? So just look at that word cloud, whether it's for genomics or for clinical trials. We've always talked about transparency, the importance of privacy, justice, accountability. So why is there a focus on AI and ethical issues? Why are we not learning from genomics, from clinical trials, from drug development pathway? This slide again also shows the ethical issues that will come up in every discussion on AI in global, on AI and health. And my question is it any different from what you've heard from other forms of global health research? Just take a look at it. But I'll focus on two in the interest of time. I'll focus on fairness and minimization of bias and human control. And I think I've talked a lot already about human control when I narrated the story of Adam, Eve, and Genesis. So let's talk about fairness and minimization of bias. The common statement you will hear in any ethics discussion is data bias, and that the data sets to train these models are undesirably biased. We need more diverse data sets. But this is still not new. It's a problem in clinical trials. And if you go to any genetic conference, I'm sure in 1 hour, all 4 speakers would have talked about the lack of diversity, the lack of diverse data sets to support genetic research. So it's not only a problem of artificial intelligence, but I think what we should be asking at this stage is, why is there a problem having diverse data sets? And I think that our quest for diverse data sets needs us to take a step back and ask ourselves if this request for diverse data sets should be combined with greater request or should be combined with requests for greater justice in medicine, healthcare, tech industry, and society. Because if we make a request for greater justice in medicine and healthcare, and we get more and more people to access these services, then access to data wouldn't be a problem. So perhaps we need to go back to the basics. Fairness is also a topical issue in AI ethics. And we have focused mainly on the data collection, in our quest to get diverse data sets. But we need to understand that data in itself is not neutral, and that the persistent social inequalities in data will find their way through processing, labeling, and classification. And as scientists who are wanting to introduce AI into our projects, do we, for example, have effective means of characterizing and or standardizing ethnic diversity in our training data sets? Have we thought about that? The second point I want to talk to is the shared responsibility of different stakeholders. And I think many speakers have talked about how they are engaging diverse stakeholders. But what I would want to highlight in this slide is the need for reflective processes for all the stakeholders. What are the perceptions that we hold, be it as policymakers, as patients, as clinicians, as scientists, or as engineers, that is informing or shaping the use of AI, and how does that contribute to the bias and unfairness? What are our underlying assumptions, and do we need to interrogate those assumptions? The second thing is about the dearth of, the absence of policies in biomedical AI in Africa. So studies by the Science for Africa Foundation shows that there is a lack of AI policies, especially in the context of health, across Africa. And the question we want to ask is, are you worried that biomedical research is moving faster than governance? And if so, why? Why are you worried about that? But for me, I think that this problem is not specific to AI. It is a general problem in global health. It is common in genetics. It is common in new product development. And we should be asking, will biomedical AI reproduce the same problems? Do we need the AI infrastructure in Africa, and why? What difference does that make? Who owns the data and algorithms that are deployed for use in low and middle income countries? And do we think that that will contribute to inequities in any way? And what implications does this ownership have for access to new innovations? Who currently controls the discourse on their use? And I hear many people say that the global north controls that discourse. Does it matter? And why does it matter to you? What are the three ethical issues that I have just presented, what would be possible mitigation strategies? Many have talked of the need for ethics from within, what many people like to call embedded ethics. And to say that we need to include the ethicist from the very beginning, and that it helps in acceptance of product and in picking up at a very early stage what the ethical issues will be. And I think that that's very brilliant. But do we also need ethicists that are outside? That's in quotes. And also, should the ethicists who are within or who are embedded in those projects, should we expect them to question their own biases? All the speakers have talked about the need for capacity development and collaboration, and I've heard constantly the need for interdisciplinary and transdisciplinary research. And I perfectly understand why. I remember that in the first DSI Consortium meeting, I met Chen Feng and I asked him, what do you do? And he says he's a civil engineer. The naive me was looking at, okay, so why are you here? And so I asked him, so you build roads? And he said, yes. And he could see the confusion in my face. And he was very kind enough to explain to me why he was here. He told me about human mobility, the airport. He told me also about COVID. And he asked what I do. And I said bioethics. And he was very kind enough to explain to me the ethical issues that his research project faces and how they try to address that. And it was a good learning opportunity for me. And I see that in all our training programs, we all have the ethics, data ethics or AI ethics, and that is brilliant. But I think we're focusing only on the data scientists. Do the ethicists need to understand the basics behind AI and machine learning to be able to carefully interrogate the ethical issues that AI and machine learning could introduce into biomedical research? So we need to this cross-disciplinary conversations and training. But importantly, I think we need to early on identify and learn ontologies for the different groups. And so the first, even for those in ethics, the one ontology I want to highlight here is ethical AI and AI ethics. I think many of us will struggle to say what's the difference between ethical AI and AI ethics. But unless we are able to identify and learn these ontologies, we will not be able to make a case for what is problematic or what is great for AI in biomedical research. So I think the biomedical scientists need to be talking about or learning or getting training in ethics and data science, and the other way around, the data scientists, it's also good to learn philosophy or to go into the social sciences, and we should include citizens in the overall process. So what's the way forward? Biomedical AI may invoke fierce, or it is already invoking fierce public reactions and academic controversies that include a large number of stakeholders. But most of the time we are anticipating the problem. And there is no agreement on what constitutes the problem, nor what is the desired solution. And there are several disciplines and stakeholders involved. So that just introduces a very complex problem. Okay, I can't get, oops. And this is my last slide. So how can we address all this? And I think that the discourse in biomedical AI can learn from science and technology policy studies, what they have often defined as wicked problems. And why this is necessary is because most of the ethical issues in AI, or AI in itself, is like a black box. And most of the ethical issues you want to ask, it's like the philosophical, or you want to answer, it's like the philosophical question, is the glass half full or is it half empty? So we need to, together as different stakeholders and people from different disciplinary backgrounds, sit in one room and disentangle the problem. We need to break up the deadlocked opposition, but we need in those discussions to embrace ambiguity and paradox. And I think that if we look at AI from the wicked problem perspective and from design thinking, we may be able to embrace this ambiguity and paradox and enjoy the benefits that AI brings into biomedical research. So I thank the DSI Coordinating Center for the invitation to be part of this panel and the funders. Thank you very much.
Right, so we'd like to please invite all the speakers up to the panel for a panel discussion, up to the stage for a panel discussion. We'll have a shorter panel discussion, but hopefully we can cover some key questions that you would like to ask. We'll be circulating microphones.
Great. Can we take our first question? Thanks.
Okay, I would like to thank every presenters. Maybe my question was even during the last presentation, the last presentation, it highlights some question. So my question is about this, and I would like to have advices from every presenters. So do you have some concern about growing of artificial intelligence using? If so, what could be the solution to face of this? Thank you.
Someone want to, I think was the last speaker, if you want to.
Thanks. Do I have concerns about AI? I think like with all technologies, I do. Am I very worried about it? Not so much. And the reason is, I think for most people, the fear has been around jobs. But I think the first keynote speaker talked about the hybrid AI, and we can see that in research, there is no way that AI can fully replace humans. And how can we address it? I think in the my last slide, I said we need to go in with a free mind and to understand that there will be no perfect solution for the concerns that we have for AI, but we should be able to approach it from a multidisciplinary and from a multi-stakeholder perspective and say, what is it particular that bothers us, and what can we do to mitigate it? But I think AI is here to stay, and we should be willing to embrace that.
Great, thanks very much. Is the next question back there? Yeah, thanks.
Thank you. The name is Dirk Brandt. I'm legal consultant working on AI legal aspects. My question is perhaps to the second speaker and maybe the last one as well. We sit with a situation where we don't have AI legislation in Africa at the moment. We have some developments in the world. The EU AI Act is almost completely accepted. Should we not use, in absence of legislation, key ethical principles that you find, for example, in Universal Guidelines on AI, the UNESCO recommendation, the G20 principles, that any country can use, but simply grab those and apply that to AI developments? In particular, in the health context, I think it's quite crucial that we bring in that ethical approach in the development of new AI solutions, and bring in the multidisciplinary aspect as well, including ethicists and legal issues. So I would like to hear a response.
Thanks. Just before we have a response, I just want to note that Dr. Moodley is apparently online as well. So if anyone has questions to him, you can also do that. Akbar.
Sure. So I'm no legal expert. However, I do agree that there are principles that are being, drafted not only in the EU, but clearly from the White House and the Biden administration too. And I think those principles can apply, but sometimes it's not applicable in all settings. And so you have to be culturally sensitive to what exists in this setting in terms of what, not only what stakeholders are being engaged, but more importantly, I think that there's going to be some regulation that develops. Simplistically, the way I think about this is that when you have an algorithm, you usually evaluate the algorithm based on certain metrics. And that could be based on AORC, sensitivity, specificity, calibration. But at some point, it moves from being an algorithm to a decision support system. And the question is, what happens then? Is a regulation around that similar to therapeutics, where you actually have to do randomized control trials, see the efficacy, see the benefits, do a pragmatic trials? I don't know what bar that we should be holding these to. I think some of the colleagues earlier in the conference said we shouldn't be holding it at a bar greater than what we do now. Otherwise none of these technologies will be adopted. And I think there's value in some of these technologies. So I think there's a lot of, thought going into this. I think if there's no existing sort of frameworks that are in existence in local countries, I think borrowing off some of those ideas are important as long as they're culturally applicable.
Thanks, Akbar. Does anyone else on the panel want to address the question? Otherwise, we'll go to the next question from the audience.
My question goes to Joyce. Joyce, I have a question concerning the speech models, and also my interest or curiosity is regarding the accents. So it was interesting to see that your speech models were able to recognize other words, which was really creative. But I was wondering, when it comes to accents and similar words but different accents, was the model able to recognize that? Then that's my first question. The second question is, it appeared when you're using the speech models, it was more listening to the radio than using speech models to get the data. Did you try to do it the other way around and see whether now, if we have a model that communicates, does it communicate in the natural voice of the people? I think that would be also an interesting thing to do, because we are working also in interventions when we are trying to come up with AI models that can actually communicate in the voice of people who are listening back. That's it.
Joyce, I think that's for you.
Yeah, thanks. That's a very brilliant question. So 2 questions. The first one is about accents. So of course, when you're starting out to build speech recognition models, these are things that you don't care about. All you care about, one, is you have a model that's actually able to work, right? To recognize an African language, Luganda, Swahili, whichever language you're interested in. So that was what we're focusing on then. But we also have a current study right now where we're looking at gender analysis of our speech recognition models, where we're now going into looking more on the intersectionality aspects around accents, around age, male, female, just going into depth of that study. And I know the results will be out maybe sometime next year. So I can provide an answer to you that specific answer next year, but it's something that we are considering and we are very conversant about. Even when you look at the way Luganda is spoken, the people where Luganda is not their mother tongue, they will speak it differently. So the models will find it very difficult to recognize and transcribe that, right? So those are things that we're actually working on currently in the lab. And then in terms of doing it the other way around, so when we're looking at a whole pipeline for building the speech recognition models, there are so many moving parts, right? So you start, of course, we started by building the models that help us to transcribe. So that's where the work came in, the ASR work came in, that you're coming in, and then you have speech, but you want to transcribe that into text, and you make sure that the text that you get is accurate. Then you can move that to people to analyze the text. But what you're talking about is text to speech, such that the models can be able to speak naturally to you. So that's another component of work that we have done. We've actually built text to speech models for Luganda and Swahili. I remember yesterday I was looking for a Swahili speaker to help me validate the models because I know nothing about Swahili, but we are building models to really understand the naturalness, thank you, the naturalness of our Swahili, of the models that we are building, which can really be applied to any domain. If, for example, healthcare domain, and you want to communicate with patients using speech, there's potential application for the work that we are doing. So yes, we can actually have a chat about how we can incorporate what we are doing with what you're doing. Thank you.
Thanks for the excellent question. It's very exciting stuff. Next question, can I just ask that you stand up so the people online can see you as you're talking? And also note there's a few hands up on this side, so maybe the mics can head that way at some point. Thanks.
Good morning. Congratulations to all the speakers for such excellent talks. I'm Sudha Srinivasan from the NIH, and this is a question as well as a comment to Dr. Shenfeng from the Inform project. Your data was really great, and one of our interests is TB and TB transmission. And as you might know, a lot of work is being done in terms of mobility and how that impacts TB transmission. And my question is, can your platform and data be applied to look at TB? Because that is one of the biggest causes of TB disease, is how TB transmits. And we don't quite understand how that works, as well as TB exposure. So, and also I know within this consortium, as well as almost on your panel, there are people who are interested in TB in Makerere, for instance. So is that something you could work with other groups in the consortium and outside of the consortium? Thank you.
Well, thank you so much for the comments and the question. Well, short answer is yes, definitely can do it. So we are looking into also publishing our data via a repository. Right now, our project 1 and 3 are helping us testing the data sharing GitHub repository. Once it's been testified, we'll also release our mobility data right now within Nigeria and South Africa, cross-border, cross-province, and within province data set. That'll be readily shared across the DSI consortium. Then to know that our data set actually covers more than 150 countries in the world, many other African countries included. So we are interested in, partner with everybody sitting here and also sitting on the podium as well, to look into interesting emerging issues like TB, also Ebola as well. We have some colleagues having such conversation offline. So yes, this data set is valuable, but we are limited in, just me and my students. Definitely that can be joined forced by all the other gardeners with good vision and interesting topic to study.
Excellent. Thanks. Next question.
Hello, good morning. I'm Charles Michelo from Across Research in Zambia, and my comment, I think is linked to a presentation from Kenya or Addis or even KwaZulu, because it's general training. I have appreciated the discussion on AI this morning and what it can do on particularly health data. And let me specifically say public health data. You realize that most of the data in public health might either be observational or experimental. And there are a lot of issues, I think some of which were raised yesterday regarding data generation and especially on observational data. I have noticed that in the training programs that has been suggested, there isn't that much emphasis also on equipping our trainees on the core domain and public health areas, so that on these areas that we can apply. I did notice that I think there was a domain on One Health and the presentation from KwaZulu and climate and health. But I noticed that there isn't that effort to equip the trainees with the core disciplines on which this data is coming from and on which the interventions and the data on the analytics or the interpretation can be applied with the sole purpose of reducing the disease burden. I'd like to have a comment on the presenters on what efforts are being done in this regard, so that the data science is not standing away from core health data, which is largely public health data. Thank you very much.
Thanks for the question. And just to note, we are running short of time, so I think we're going to take 2 questions after this maximum. Otherwise, we're going to run out of tea time. Anyone on the panel want to pick up on the question around training and health data? Okay.
Okay, thank you for the question. In the training programs that we've had that we're having for the MSc Public Health Data Science program, we're trying to balance the courses in the 2 years that the students are staying within the program. So we have public health, statistics, and data science. We also understand that the domain expert or the domain in the public health domain, we need some more courses, but the courses are limited. So we wanted to focus on more on data science, where the expertise are lacking. But having said this, there are seminars that we plan to organize, mostly coming from public health, so that mostly the IT and the statistics background students will have more exposure on public health. That is the idea that we are planning, if I have understood the question correctly. Thank you.
Thanks, great. I think we have our last question. I'm sorry, you can always pick up with the panel members later. We'll take our last question now, thanks. And then one last reflection from the panel. Thank you.
Thank you very much. I'm Elvis Zikum from Yaoundé, Cameroon, from the University of Yaoundé 1, and also member of the World Health Federation Air Pollution and Climate Change Expert Group. I'm really impressed by all the presentations, and I want to ask just two simple questions around first climate change and how I know data is lacking in the continent. And when we speak about climate change and using be it artificial intelligence, and I'm really impressed around the work Ethiopia and Kenya are doing to include in the school curricula. I just want to be sure to know how easy it will be for you now if we pick something like climate change for you to get data, given that you have included this in the curricula. Will it be easy for you to include like climate change, collecting data, or even mainstreaming it in the school curricula so that the students who will be in this first cohort or after the finish, they can now go on the field to collect data? So this is something I want to know. And the last thing is really about conflict of interest. I know here we are talking about data, but I'm just wondering if there is any enemy around this issue. For example, how secure, if we talk about AI and big data, is it like always obvious that everybody who is coming in here is clean, such that when we go out and we know that every data which is here is protected? Not that you cannot use, but just that I've worked in other areas where we feel like there is a conflict of interest, which you will not know who is coming in, how are they using the data they are getting in here, especially if we are talking about big data and artificial intelligence. Thank you.
Thanks, and well done for sneaking two questions into one. Who wants to take the first one on bringing climate change and climate data into the training curriculum? No.
Well, I can speak on that as well. I know Henry also mentioned about climate change data. So in my view, yes. So we started some data that's on the public domain, including the data set about the weather, precipitation, temperature. Then into some specific climate change related events, we figured the limitation of the data really prevented us from moving forward. For instance, how can we know the high fidelity information about the flooding? Right, that's the part we're trying to address. Then that brings us towards the broader civil engineering domain, how some of the environmental engineering research that's sitting there can be leveraged. So that again calls for a broader search of collaborators, engineering school, CS. We have, for example, the technology of the satellite image sensing is something we brought to our climate change supplement grant, of course, thanks to the NIH support. From there, we can really leverage the big data approach. As you can see that we are using time-to-time mapping of the flooding, and using that and link it towards our mobility data together, we gradually build up the capability that's really high dimensional, including environmental, transportation, human, and health related records. Then we were gradually strengthening the climate change data. Then we are also trying to also transfer the knowledge via a pilot grant under Inform Africa, building some hybrid modes of training sessions, boot camps, to generate broader interest and knowledge transfer activities, educating our university students, practitioners, how such a data generation could be done, right? I think these are something that we are thinking along the line of generating climate change data, which is emerging. Then in answering your question about the conflict of interest in data, well, we're just trying to stay in the transparent domain. We will release our repository, releasing our algorithms that's helping us generate the data, so that we are staying clear how this is generated. I know AI is sometimes treated as a black box, but we're trying to make it a white box That way, hopefully some of the conflict interest debates can be addressed that way. But I'm also a student in this area, trying to learn from all of you how these challenging questions could be answered as a whole together, as a team together.
Great, thanks very much. I'm getting signals from Francis. Is Deshan wanting to say something online? Is that right? I'm amazing at sign language. That's brilliant.
Hi, Chris, can you hear me?
Deshan, do you want to make a comment?
Yes, can you hear me?
We can sort of hear you. Can you want to try again?
Okay, now, is it better?
That's brilliant, yeah, thank you.
Okay, so this is the first question about availability of data. So if you're looking at the climate data, I suspect Chris can also comment on this, but so in Africa generally, it's not just climate data. We do not have the same data sets as probably the developed world, and these, there's fidelity problems, there's data cleaning issues, and all of those things. So if you're looking at what I would call a data scarce environment, then we need to create new AI techniques that work in these types of environments. And for me, that is the big issue, is that we're not putting enough resources and enough focus on creating core AI techniques that work for our context on the continent. And so rather what we're trying to do is to put a lot of focus on creating these large data sets, which are available in the developed world. So for example, if you have some low fidelity data and sparse data or sketchy data, and then you can fuse it with, let's say, the available satellite imagery and so forth, and then you create AI techniques that can work specifically on those types of data sets. For me, that's a very powerful approach. The link to that is the, I think one of the speakers mentioned that we actually consumers of AI algorithms that are developed elsewhere. Linked to that is that we should be producers of new AI algorithms that generally can be customized for our settings. And I think that is something that is not discussed enough, like why are we not doing that? And then that is for me also linked to the ethical issue, is that this is an inequality. Rather than regulating what's developed elsewhere, which is not developed specifically for our settings and may not even work properly in our settings, why aren't we creating technologies that work for our settings and then trying to regulate that or worrying about the ethical issues around that? Yeah. So those are my comments. Thank you.
Thanks so much, Deshan. Those are really nice comments. Particularly the last comments, I think, are really useful way towards almost wrapping up. But I do want to give Henry a chance to make one quick comment before we close off. I know I'm standing between you and caffeine and glucose. So
yeah, thank you very much. I just want to make a comment regarding addressing issues of domain areas. I think you can see clearly the way I presented the structure of the short courses. They were basically having a component of methods and domain areas. So in this particular presentation here, I covered health system strengthening, climate change, food security, and so forth. So definitely in the final program, which we plan to launch, it will strongly cover both areas. That is, the domain areas will have to be probably covered in the context of public health and other related areas. So regarding the question of dealing with complexities such as observational data and experimental data, yes, we know that such data has lots of complexity, confounding, missingness, and so forth. So definitely the methods courses which we are going to develop are going to include ways of dealing with such complexity such as confounding, missingness, and so forth. So yes, we are very sensitive on that, and we are definitely addressed. That's why I said that the way we are developing this program in UKZN is that the short courses we have offered inform us on what we are going to include in the final program, which is going to be launched. So it will be complete package, both on the method side and also on the domain area applications. Thank you.
Thank you so much. And at that point, we're going to end off this session. So if you could just join me in giving a round of applause to our speakers and panelists. Excellent. And thank you all for all the excellent questions. Yeah, and enjoy your tea break. Thank you. I want to ask you, for the mobility data you're using, what data is that? Is that the Google?
It's combined of different apps, and also social media, in the vehicle GPSs, all that.
And is that all sort of collected into cohesive data sets, or do you pull that all together?
So rather than we just look at latitude, longitude, and the timestamp of the device.
Okay.
Then we're using the algorithms to turn those into number of trips. And activities as well. Trips being, traveling from point A to point B.
Activities is where they're going.
Yeah, activity I've been seeing in one place for a couple minutes, hours, doing something. I think that's towards point of interest. So to understand the purpose of the travel, are they going to grab a food or working? All that.
Okay, oh, that's great.
So it's a lot of data, terabytes of data. Yeah, I know it's
last thing to say.